Hey guys, hello. How are you guys? I'm fine. Today was a long day, and I tried to upload several videos that I took in daytime, but I failed because I didn't know how to deal with devices, and finally I came here to make it the video that is not that good quality. I mean, mechanically uh, good quality. But I realized that this is just so HD. It's totally enough. So I'm gonna start with this quality, and yeah, let's have a start. Tonight, I'd like to talk about the what physics is, because I often think that what science is and what physics what is and where is a physics is located in the field of the science. Is it above the mathematics or is it below the mathematics? What does it mean below or above, up and down? So I tend to think that the physics is a fundamental, the basic principle that cover all sciences like chemistry, biology, even mathematics. In fact, I was wrong. I'd say mathematics is a root of the science. But as a starting point of the science, physics is the best way to get enter to get see what's going on in the field of the physics. So I got a textbook called "Great Idea of Classical Physics" by Professor Steven Pollock. He's a professor at the Colorado University or Denver University, whatever. He's one of my favorite professor I've ever met. I mean, virtually met. So, and on this book, in the very beginning on this book, he summarized the the idea of physics in just 2 pages. So I'm gonna speak out what he has written, and yeah, consequently, I this tells me what physics is, and yeah, pretty much so. So let's begin. Great idea of classical physics. Scope. Physics is a science that tries to understand the deep principles underlying the world we live in. It's about understanding and describing nature. It's about things, the things, yeah, as opposed to the biological or even chemical systems. So this is not the physics is not describing the system. No, no, no. The physics is only applied for in between two objects, not more than three objects. So if you look at the things uh, uh, more than three, you focus on the chemistry because chemistry is a subject about dealing with more than three objects like molecules, atoms, yeah, whatever. So let's get back and yeah. How do things move? Why do they move? How do they work? Physicists search for deep patterns for the fundamental simplicity and unity of measurable phenomena. Yeah, it is always measured by devices or naked eye, you know. For the fundamental simplicity and unity of the measurable phenomena, in this course, we will follow a theme-based quasi-historical path highlighting the central concepts, ideas, and discoveries of classical physics. Oh yeah. Classical here refers to the scientific work done up to the start of the 20th century, that is, essentially all physicists before the quantum theory and relativity. It is a physics of the everyday life, the physics of a deterministic clockwork universe, yeah, with enormous explanatory and predictive power, We will spend a little time getting to know the characters who play key roles, including Galileo, Newton, Faraday, Maxwell, and others. But the emphasis of this course is on sense-making. Yes. What have physicists learned about the world? What are the key underlying laws of nature? What are the primary organizing principles? How can we use these ideas and connect them to our personal experiences? Right. Physics is a broad field of the study. Physics is a broad field of study and can be approached from many angles. We begin with the venerable branches of physics known as mechanics, the study of force, energy, and motion. The word mechanics might make one think of car engines, and in some ways that's a good metaphor. Engines are complicated, but they are built out of simple and comprehensible parts, each of which serves as a simple purpose. When put together, they create a familiar, useful, and understandable by mechanics whole. But mechanics in physics is not about cars, of course. It's the study of how just about anything moves and what makes objects behave as they do. When acted on by force, the force is the key word in physics. So let me tell you the unit of the force. Force is expressed as kg, kilogram, mass, times the distance, meter over a square time, so square second, kg, pretty much. And so you can see there is three elements combined. Again, mass and distance, also time. You will appreciate in the end of the lecture, because this unit describe how things are orchestrated very beautifully. Let me get back. I'm sorry. It's a study that will help us understand the vast and disparate array of phenomena, from Olympic high divers to the display of sparks in a firework on the 4th of July, Independence Day in the United States. I am in Japan. He's American. Anyway, to the path of the moon in the night sky, or the ceaseless bounce and jitter of atoms in a gas. We will focus on the central concepts. What do we know, and how do we know it? We'll ask where the idea came from and how we might test them. And of course, we'll ask what we can do with this knowledge. What we can do with this knowledge. This is important. This is classical mechanics is primarily the physics of Isaac Newton. Primarily the physics of Isaac Newton and a host of other brilliant characters who laid the groundwork for understanding the world that is still relevant 400 years after its beginnings. Wow, that's wow. Our goal is to walk away with a sense of the order and coherence, the basic structure and principle of the foundation of physics. Right. Mechanics sits underneath the rest of the physics, a bit like the foundation of a great cathedral. The second half of the course will add the edifice, structure, and turrets. We will need to understand the idea behind the electricity and magnetism force that dominate our technological world and lead to understand of the structure of all matter and light. This investigation leads naturally to optics, which was unified with electricity and magnetism in a brilliant stroke in the mid-18th century. Yes. Yeah, 18th, yeah, thousand, yeah. In this context, we will briefly consider waves and the myriad phenomena that become understandable and intimately related to one another once we grasp the basic idea and the consequences of vibrations. Yeah. We will need to learn separately about heat and thermodynamics, a branch of classical physics that deal with everything from understanding car engines and power supplies to making a perfect cake. It's gonna be yummy. This course of study takes us right up to the start of 20th century. One final statement, comment. Mathematics plays a special role in science, not to mention one very dear to physicists, but we will not and need not focus on the math in this course, although skipping the equation limits, to some extent, the depths to which we can learn physics. The concepts themselves are, by and large, sensible, intuitive, and comprehensible through the metaphor, life experiences, ordinary logic, and common sense. From time to time, however, we may follow brief mathematical detour to appreciate the power and beauty of more formals or symbolic reasoning. Thanks for watching tonight. See ya.